I welcome you all to Part B simulation experiments of Analog Circuits Lab 18 ECL 48. Today we are going to learn about Astable Multivibrator. An Astable Multivibrator is an oscillator circuit that continuously produces rectangular wave without the help of external triggering. So, Astable Multivibrator is also known as free running multivibrator. Copy. Experiment 4th A. Aim to simulate A-stable multivibrator using 555 timer IC. Components required: IC 555, 1. Resistor 4.7 kilo ohms, 2. Capacitor 0.01, 1, 0.11, VCC 10 volts, 1, which means a power supply, and CRO 1. Circuit diagram. Circuit diagram of 555 timer A-stable multivibrator. 8th pin and first pin of IC are used to give power, VCC and ground respectively. The 4th pin, reset pin, which is active low and is connected to VCC to avoid accidental resets. 5th pin, control voltage, which is not used. So, to avoid high frequency noises, it is connected to ground using 0.01 microfarad capacitor. The trigger and threshold pins, input pins, are connected to capacitor, which determines the output time. Discharge pin 7 is connected to resistor RB or resistor R3 such that the capacitor can discharge through R3. And so VCC is given 10 volts. VCC and reset is shorted to 10 volts and 4.7K. R1 is 4.7K. R2, make it as R2. It is 4.7K. C1 is 0.1. C2 is 0.01 microfarad. It is 0.01 microfarad is connected across CON to ground, control to ground, and threshold and trigger pins are shorted and given across R3 to 0.01 capacitance, and discharge is given across the resistors. And output pin number 3, output is given to CRO and ground is connected to ground. So here for output I am connected 2 channels in CRO. One is given for the output and another one is for the triggering pulse. At the output, to take the triggering output, I am connected 2 channels. So let's see the ideal graph. Ideal waveform. So this is the rectangular pulse which is coming at the output, ideal waveform, and the triggering is taking place at 1/3 of VCC to 2/3 of VCC, and the duty cycle of this design is 66.66% duty cycle. let's go for the simulation. Double click on the MultiSim. Go to place, component, master database, all groups and all family. Type 555. Take 555 virtual. Resistors of rated, or directly I can take 4.7k, but I will take rated in two numbers, and capacitor rated two numbers, and VCC. Ground. Okay. Rotate clockwise such that as shown in the circuit diagram. First, connect the pin number, which means control to ground across a capacitor, and connect it to ground, and then trigger and threshold should be connected. Resistor end is connected to VCC, and from VCC to reset and VCC are connected to VCC pin. Discharge pin should be connected across the resistors. And threshold and trigger is connected, and merge. So lastly, connect the capacitor to ground. Now R1 value is 4.7 kilo ohms. R2 4.7 kilo ohms. C1 0.1 microfarad. C2 0.01 microfarad. And the output pin. So take the CRO oscilloscope, connect it to output pin. Connect the negative to ground and connect the second one channel 2 to triggering output. So this completes my circuit. Let's go for the let's do simulation. So click on run button, double click on CRO and click stop. Vary the time base axis, which means x position to 1 millisecond approximate, and you can vary the voltage. So now we are getting our output. Let's analyze the output. So 5 volts channel 1, so I will vary my time base such that I have to get T on. So 6 8. Okay, so I am calculating T on. So T on is 625 milliseconds, which time base is 1 millisecond. So the duty cycle is of 62.5 percentage. So as I said, it's a free running multivibrator. So to get 50% duty cycle, I'm going to connect one diode across the R2. Across R2, I will going to connect one diode to get 50% duty cycle. to get 50% duty cycle. Place components diode. So in diode I will type 1N4001. So place it, rotate clockwise such that the anode should be connected to discharge pin and cathode to triggering. Okay, now I will run for 50% duty cycle. So we are getting 50% duty cycle here. You can see both the T on and T off will be equal. Both T on and T off are equal. So this completes Astable multivibrator circuit. Thank you.